Good evening, class. Welcome back. So we'll go with exercise 12.2. Okay, so we'll first go with the introduction. So this is the introduction. We're talking about circles, right? So here you see the word sector, right? So sector is actually an area. Okay, it's an area. This area, the area enclosed by two radius. See, these are two radius and an arc. This given line is called an arc. Okay, clear? So an arc is actually a portion of the circle, so it could be anything here. You can call this an arc, you can draw a portion of this, and you can call this an arc. Clear? It's not the entire circle, it's just a portion of this outline, okay, the circumference, so you can call that the arc. So the sector is the area, this area which is enclosed by given by two radius. Okay, it's an area enclosed by two radius and an arc. This is called the minor sector. Now if you think about this remaining area, I can also say that this area is enclosed by two radius. Look at this, it is enclosed by this radius and this radius. Clear? So by the definition of it, I can call this remaining area as the major sector. Okay, so the bigger one is called the major sector, the smaller area is called the minor sector. Okay, now you look at this, it is what? It is enclosed by this radius r and then an arc. And what did I tell about an arc? Arc is not the entire circle, circumference of the circle, it is a portion of it. So from here to here, it is one portion. So that from here to here, okay, this entire thing, you can even call it arc. Okay, arc could be this much, or how much you want to take, but it should not be the entire circle. That's it. Okay, so that is what we mean by arc. Now theta refers to the angle. Okay, usually the angle. So sometimes they'll give an angle. So this is theta. Okay, clear? It is the angle in which the two radius are inclined. Okay, so what you have to know from here is you have to know the area of the sector of angle theta. You have to know this formula, very important. The formula is theta by 360 into pi r square. Clear with this? Okay, the next formula you have to know is length of the arc, length of an arc of a sector of angle theta. Okay, and this is going to be theta by 360 into 2 pi r square. Clear with this? Okay, alright, so that is the length of the arc. Okay, so that means this area usually we're talking about this length of this area of a sector theta corresponding to this, okay, theta, the angle. So this is the formula. Clear? The next thing that we move across is segment. Remember, okay, pay attention, this is sector, this is called segment. What is a segment? Is if you're able to draw a straight line, not from the center of the radius. Okay, it should not touch the center of the circle. From anywhere apart from the center of the radius, you call that the segment. Alright, if you're able to draw one here from one end to the other end, you can call that as the segment, and this is called the minor segment. Okay, and this entire region will be called the major segment. Clear with that? Alright, okay. Alright, so see, even from here to here, if I can draw, I can call this as a segment again, no problem. Okay, again, or even from here to here, this area, this is also called the segment. Alright, from one end to another. Okay, that's it. Clear with that? So minor and major segment. Okay, so in the case of this, you see the smaller area, in the sense the smaller area will be called the minor segment, the larger area will be called the major segment. Okay, so be careful with that. So in order that, so how do we find out? We don't have a specific formula, okay, for finding out the area of minor segment, but what we can do is we can actually use a technique. So suppose I draw a line from the center of the circle to this. What does this? Becomes automatically the radius, and this becomes the radius. So you look at this, doesn't the graph look something like this? You look at this, not the perfect drawing, but something like this. That means if I want to find the area of this, what can I do? If I find out the area of this entire region, so what is this? Just try to ignore the line now. Okay, so this area, this is called the minor segment, right? A small area, but what is this area? You look, what does a sector look like? Sector look like this, right? You look at this, look at sector. That means this area from here, you see, from here to here is also another sector, right? So if I'm able to calculate this entire sector, then okay, after that I subtract it with this triangle. Look at this. Okay, you look at this. I take the area of this entire segment and subtract it with this triangle. You see OQP. Does not it look like, isn't this a triangle? Straight lines, everything. So if I take the entire area of this sector and subtract it with this triangle, I will be left with this blue region, okay? And that is how I can calculate the minor segment. Here FC, and then this is another definition. I mean, this is what arc means, okay? So even from here to here, it does not matter how long, you can also call this as the arc. Clear? So that is one thing, okay? See, I'll just, from here I think you can draw. This is a sector. This is a sector, you agree? Now if I find out the entire area of the sector and then I draw a straight line here and then subtract it with this area, so I'll be left with this, right? Clear? Alright, it's like you color 15, okay? You have a, just imagine you have a ruler of 15 centimeter and you color it with black, okay? You color everything with black. Then you have 15, okay, suppose, and you color everything it with black color, okay? 15 centimeter you're covering it with black color, and then you again you take this 15 centimeter scale which is covered in black and subtract 13 centimeter from there. You'll end up getting some remaining portions, right? It's something similar to that, okay? That's not the best example, okay, never mind, we'll just move on to the next, to the MCQ. Clear? So you look at this. What is the quadrant? What do you understand by the quadrant? Quadrant actually refers to 1/4 of anything, okay? Quadrant means 1/4. So 1/4 of a, in this question they have given 1/4 of a circle. So what is 1/4 of a circle means? You look at this. This is the circle, okay? Now you look at this. This is 1/4 of a circle. This graph you can see 1/4 of a circle. How do I know it's 1/4 of a circle? That means one part out of the 4 parts. What I mean by this is, you look at this. If I draw two straight lines, how many parts are you getting in the circle? 4 parts. So I am taking one part out of the 4th part. Now if I take 2/4 means 2 parts of the 4 part, means I mean half of the circle, right? So I'm considering these 2 parts. Look, I'm saying 2 parts out of 4 means I'm considering these 2 parts. So if I consider this 2 part, is this not half of the circle, right? So this is the same explanation. 1/4 means 1/4 means this, okay? 1/4 of a circle. So I'm just taking this one particular area. Now 1/4, 2/4 would be something again like this. See, okay, not the best graph again. And then 3/4 would be again. This is, the graph does not look that good. Okay, but I hope you're clear with that. 1/4 of a quadrant, okay? 1/4 of a circle. Clear? So this is what we mean by 1/4, okay? So here you remember, okay, I will not again dive much into it since this is MCQ, but perimeter of a quadrant of a circle. You just remember this formula, okay? Quadrant of a circle is actually pi/2r plus 2r. Now you can take the value of pi as, try to stick it with 22/7, okay? Only if they've mentioned pi as, if they have given us hint as 3.5, you try to stick with this. If not, try to stick with 22/7, okay? So I can write this as 22/7 divided by 2. What is radius? 7/2 centimeter into 2 into 7/2 centimeter. Sorry, this is plus, okay? So you can cancel out 2 and 2. So you can cancel out 7 and 7, okay? Now you can cancel out 2 into 11. So you're left with 11/2 centimeter plus 7 centimeter. Now 11/2 is actually 5.5 centimeter plus 7 centimeter. So this becomes 12.5 centimeter, option number 4. Clear? See, 11/2. 2, 5 times 10, you're left with 1. Take decimal point, the 0 will come down. 5 into 5, 10. So 5.5. Clear? The division of this. Now quickly moving on to the next question. The area of a sector of central angle. Central angle. Remember what I told you about the angle? Theta means the angle, right? So here they have already given us the biggest clue. Theta is given as x. That means it's the central angle. And the radius is given as 4r. So the area of a sector of central angle x of a circle radius 4r. We are asked to find the area of the sector. So area of sector, what is the formula of, what angle are we talking about right now? Of angle x. So this will become x by 360 into 4 into pi r square. So x into 3 x divided by 360 into, put pi as it is, okay? Since in all the options see they have not replaced pi, so don't interchange, okay? You look at the options also, they have kept pi as it is, untouched, so keep it untouched, okay? Into, what is r square? R is 4r, so I can write it as 4r the whole thing square. So x by 360 into pi into 4r into 4r. So 4 into 4, how many times 36? 4 nines are 36 and 0. Now you have 2. 2 times 2s are 4, 2 times 4s are 8 and 45. So you're left with 2 pi, look at this, r and r square x by 45 degree. That means the given answer for this is going to be 2 pi r square 45 degree is going to be option number 2. Clear with this? Okay, see they have given central angle. Remember, theta means angle, okay? Clear? So sometimes theta, if they say the angle is 60 degrees, suppose the question is asked like that, you must understand they're talking about theta only, okay? Because theta means angle. So quickly moving on to the last question that we'll be doing for this video is this. An arc of a circle of length 5 pi centimeter, okay? And the sector bounds has an area of 20 pi. So let's go with this solution. Now let's go with the area, okay? First with the area, okay? So what is area of a sector? Area of a sector, they have given it as, clear, okay? I want you to read carefully. And the sector it bounds, remember, okay? And the sector it bounds has an area of 2 pi centimeters. So we are talking about area of a sector, which is this. So this area of a sector is pi by 360 into pi r square equal to 20 pi centimeter square. Clear with this? Now you look at this. This is where students may make an arc of circle. An arc of circle. They are not talking about arc of a sector. They are talking about arc of a circle. Clear? So since they're talking about arc of a circle, okay, this arc, that means since they have already mentioned arc of a circle, so they're actually referring to the entire circle, okay? So they're considering the circumference. So arc of a circle, what have they given it as? They have given it of length 5 pi centimeter. Clear? All right, so the arc of a circle is going to be theta 360 into 2 pi r equal to 5 pi centimeter. This is the difference, 2 pi r, because they are talking about the arc of a circle. Clear? Arc of a sector formula is pi theta 360 into 2 pi r square. See the difference? This is sector and you're talking about here just a circle. Clear? Why 1 r? Because see, since you're talking about the entire radius, you just have to take one radius itself. But when you talk about sector, what happens? A sector area is enclosed by 2 radius. That's where the value r square comes in, okay? There are some explanations for that. Maybe we'll leave it for some other day. Therefore, what I can do is I can say this is my equation 1 and equation 2. Okay, so now you write dividing equation 1 with 2. So that would be pi by 360 pi r square equal to 20 pi centimeter square divided by pi by 360 2 pi r divided by 5 pi centimeter, right? So you can cancel 1 centimeter, cancel pi and pi, 5 into 4. You can cancel this, you can cancel this. So you're left with r by 2 equal to 4 centimeter. So r will become 2 into 4 centimeter. So radius will become 8 centimeter. So that is option number 3. Clear? We have been asked to find the radius of the circle, so 8 centimeter. Okay, so we'll end it here, and I'll do the next remaining questions in the next video.